Welcome back. That first lecture is the longest of the year. So they're never going to be that long again. That one's always just long. 4.2, welcome back. We're talking about gathering the data we need to draw some conclusions. That's what we're doing in statistics. We're making decisions when we don't know everything. That's what statistics is. One of those ways we can gather some data and figure something out is do an experiment. So we got a bunch of vocab here. I can keep saying it. It's vocab heavy at the beginning. So we've got some words here, a lot of words in our Comic Sans. Experiment. Investigators apply treatments to experimental units and then proceed to observe the effect of the treatment on the experimental units. Okay. So we've got our definitions loaded with more words that we need to be aware of. Treatments, okay, probably going to come up. Experimental units, okay, so more words we got to think about. In a randomized experiment, investigators control the assignment. Assignment. Who gets what of treatments? Oops, sorry. Using a chance mechanism, like the flip of a coin or a random number generator. So assignment is going to be a chance method, something that's done randomly. So we've got experiments. Well, that's fine. I'm messing up my pen. We've also got the other thing. Maybe we can't apply treatments. Maybe we've got to do an observational study. Is breathing cobalt dust bad for Park Hill High School students? And we take half the class, and half of you are going to breathe in cobalt dust, like you're in the cobalt mines. You yearn for the mines, and the other half of you won't. We're going to decide that randomly. No, why aren't we going to do that? It's probably some harm associated with that treatment. So oftentimes, observational studies, we're going to have to do those when we think there's some harm associated with the treatment, because we don't want to intentionally give someone something that we believe to be harmful. So we've got the same question with lung cancer. We don't get to randomly assign smoking. Half the class is going to have to smoke a pack a day, and the other half does not get to smoke cigarettes. We don't get to do that. So we can't assign harmful treatments if we know they're harmful. You know, ethical considerations. Some of you in AP seminar, AP research might be having to think about those ethical considerations. So summary of observational versus experiment. What do we got down here? Observational study observes, okay, observes individuals, measures variables, but does not attempt to influence. So no influence. An experiment imposes some treatment. That's a good word there, imposes, puts it on them to measure their responses. So when you're talking about experiments, you need to talk about imposing, maybe administering, maybe giving a treatment. If we want to know about cause and effect, what do we got to do? We've got to have that random assignment of treatments. We're going to talk about cause and effect. What does that mean? We can say that this thing causes that thing. How can we say that this thing causes that thing? Random assignment helps us get there. We'll talk more about that later on and in 4.3 as well. 4.3 is very short video. It's going to be about 3 minutes long. So evens us out from 4.1. Moving on. We've got some examples on the back. We're going to move through these pretty quickly. I don't even like that top example. But we're going to skip to this next thing, which talks about experimental units, treatment, and subjects. So we got some more vocab. What are these words? We got to know what they mean. The specific condition applied to the individuals is a treatment. The thing that they get. We can talk about, maybe it's a fertilizer put on the plants. Maybe it's the type of class somebody takes. Maybe it's, I don't know, whatever we're learning about, what kind of lunch they eat. That's the treatment. The experimental units, okay, are the smallest collection of individuals to which treatments are applied. If they're human beings, we don't call them experimental units anymore. We call them subjects. So we want to recognize the difference in our humanity or something here. All right, so what are we going to have to do? We're going to have to often, first thing we're going to have to do is when we're looking at a description of an experiment is we're going to have to identify, well, what's the treatments, what's the experimental units, what's the thing that we're measuring the response to? And that's the thing you could do on the very next problem. We are trying, this was a study done at the University of Nebraska. They were trying to get the birds, what are they trying to get the birds to not eat the corn? They're eating all the damn corn, and we would like the birds to not eat the corn because we want the corn for you in the high fructose corn syrup, or the cows for you in the hamburgers. So let's take a moment to read through this. I've cut this down. This was a 3-part FRQ. We've cut it down to 1 part, and you're just doing the first part, the easy part, where you can see you're going to identify the treatments, the experimental units, and the response. Let's take a moment, do that. Should be able to do that without too much trouble. Take a moment and read through it. Agricultural experts trying to develop a bird deterrent to reduce costly damage to crops. Great. Experiments to be conducted using garlic oil to study its effectiveness as a non-toxic, environmentally safe bird repellent. Okay, we're trying to keep the birds away. Experimental use European starlings. Okay, a bird species that causes considerable damage, all right, to the corn crop in the U.S. Food granules made up of corn are to be infused with garlic oil at 5 concentrations of garlic. Okay. 0, 2, 10, 25, and 50. The research were, all right, so food granules, that seems important. The research will determine the adverse reaction of the birds to the repellent by measuring the number of food granules consumed during a 2-hour period following overnight food deprivation. That seems like the response variable. We're just going to copy that. The number of food granules consumed during a 2-hour period. Great. That's what we're measuring the response to. Who's getting the food? The European starlings. There are 40 birds available for the experiment. The researchers use 8 birds for each concentration of garlic. Each bird will be kept in a separate cage and provided with the same number of food granules. What are the treatments? The granules with different concentrations of garlic. So those are the different treatments. They're getting granules with garlic in them. Who's getting the treatments? The European starlings in their cages. Great. We just need to be able to identify what's being delivered, who's it being delivered to or imposed, and what are we measuring in response. So what worked the best? I don't know. Ask me in class. I'll pull up the paper. It works. So keep cooking. Some more definitions. We're doing experiments. We're not always going to measure everything of interest. Sometimes there's going to be variables hanging around. There might be a lurking variable that's not among the explanatory response variables in a study, but may influence the response variable. So this is just something, I don't know, we didn't measure it. Didn't measure it, but it could be important. We don't know if it's not. It's just lurking. What's lurking? Hiding around the background, okay? Creeping around the corners. Lurking. What else do we got? We have a higher bar here. The second thing is called confounding. Confounding. Confounding looks like it could be confused. Confounding occurs when two variables are associated in such a way that, so they're associated in such a way that their effects on a response variable cannot be distinguished from each other. And that's, what the hell is that talking about? You might have heard something like this in AP psychology. We say, hey, it looks like this thing has to do with that thing. It looks like these two things are influencing each other. But really, there's this other variable that's kind of in control of things. What might have you seen in AP psychology? You might have seen something about how, well, when ice cream sales went up, there was more polio. Ice cream and polio. You might have also seen it as violent crime. Those are the two that are commonly introduced here. And it looks like, okay, these things have something to do with each other. People were worried. They thought, oh, shit, people are eating more ice cream. I swore. When people are eating more ice cream, they're getting more polio. Or maybe they're getting more polio and they're eating more ice cream. These weren't really the things. What was really the thing that controlled this situation? The thing that really controlled it was temperature. Temperature. It's the summertime. People eat ice cream. What else happens in the summertime? Polio virus does a little better. So temperature was the confounding variable. Down below, you've got another example. This is actually the answer. This is the answer for part C. It's already written out for you. But I want you to look at this situation, take a moment, pause, and say, how is this a confounding variable before you just read the answer? Let's take a look. Alzheimer's disease results in a loss of cognitive ability. Scary. Beyond what was expected during typical aging. A local newspaper published an article with the following headline. Okay. Study finds strong association between smoking and Alzheimer's. Okay, so what do we got right now? We've got this thing where it looks like smoking, and what does that go along with? Alzheimer's. So that's kind of the situation. Right now, it looks like, hey, smoking, Alzheimer's. Looks like they've got something to do with each other. Maybe you smoke, you get Alzheimer's. Maybe you get Alzheimer's, you want to start smoking. I don't know. It's probably one of those directions. A. Article reported that study tracked some people who were smoking. It wasn't an experiment. This had to have been an observational study because we can't make people take cigarettes. We can't make people smoke cigarettes, especially if we think the cigarettes are going to give them Alzheimer's. Bad. All right. Some people who smoked at least 2 packs of cigarettes a day, the risk was 2.75 times the risk. Okay, so it looks like smoking makes your Alzheimer's risk go up. Well, is the study described an observational study or an experiment? Okay, so we got the answer to part A. It's an observational study. Why do we know it's an observational study? Because treatments were not imposed. Not could be applied, could be imposed, could be administered. And the treatments in this case would be smoking or not. And then I've skipped part B for reasons. And it says part C, exercise status was mentioned as a possible confounding variable. So what does that mean? Explain how exercise status could be a confounding variable in the study. So really what we're saying is exercise is up here. And exercise might be the thing that drives both of those other two. Why might exercise be associated with smoking and Alzheimer's? Confounding variable is one that is related to the explanatory variable and possibly influences the response variable. How could exercise be related to smoking and influence Alzheimer's? Well, maybe, hey, maybe if you're exercising a lot, you're not smoking a lot. In this case, it seems plausible that people who exercise might be more health conscious and then less likely to smoke. Okay, that makes sense. Similarly, it's possible that people who exercise more regularly less likely to develop Alzheimer's. Okay, maybe it's not the smoking. Maybe it's not, maybe it's the exercise. If you exercise, you're less likely to smoke. Maybe if you exercise, less likely to get Alzheimer's. If both of these relationships turn out to be true, then smoking would be associated with developing Alzheimer's, even if there were no cause and effect relationship. So confounding that your explanations of confounding are going to be long. You've got to say, okay, it looked like these two things were associated, but how could this thing have been associated with that and with that other thing? So you kind of have to imagine this triangle when you're considering a confounding variable, and make sure you talk about all the arrows. That's basically what's happened. This was the keyed response. Are you going to write all that? No, but you got to write some of the key parts of it. Key parts are what? Basically describing each arrow. What else do we have? We have some more down here at the bottom about completely randomized design, another vocabulary word written in bold for what's a completely randomized design. Treatments are assigned to the experimental units by chance. It's the hat method. It's essentially this random assignment could be the hat. What do? We've got a bunch of people, and some of them are going to get I don't know, Cocoa Pebbles, and some people are going to get the Cocoa Dino Bites knockoffs. I don't know. I like the Dino Bites. How are we going to select who gets what? Put a bunch of ones and twos on pieces of paper in a hat, shake the hat, pull them out one by one. And we'll go through some work of describing those methods. These completely randomized assigned methods, we're going to talk about hats. Some may include a control group. What's a control group do? More definitions. Inactive treatment. Placebo effect is the response to that dummy treatment. And double blind, another one of those things we're going to have to know about. Neither the subjects nor those who interact with them. Two people. Person getting the stuff and the person doing the giving. Nobody knows which treatment they receive. So vocab is heavy. This is heavy in vocab. Make some note cards. Do it sooner rather than later. What do we got here? 2 more pages of these notes, then we're done. I told you it was not going to take as long as 4.1. 2 treatments, A and B, showed promise for treating a potentially fatal disease. Okay. Randomized experiment was conducted to determine whether there's a significant difference in the survival rates. Okay, so we want to see, is there a difference in the survival rate? Great. Okay, some people received A, some people received B. Treatment A can only be administered as a pill, and treatment B can be administered only as an injection. Okay, so the 2 treatments are different. So what is it? A is a pill. Sorry, A pill. And B is what is it? Injection. Okay, now I got to draw a syringe. This is fun. And that's B. All right, so A looks like a pill and B looks like a syringe. How can we make this double blind? Can we do a double blind experiment? Why or why not? They can't know which one they're getting. How could we trick people into not knowing which one they're getting if one comes as a pill and one comes as an injection? What could you do? You could make a placebo pill. What else could you do? Got to make a bigger one here. You could make a placebo injection. So the idea is how could you confuse them? How could you keep them in the dark? How could you make them unsure as to which they're receiving? They're going to have to get a pill and an injection. Give each, what are they called? What are they? They're not experimental units. If they're people, they're called give each subject both an injection and a pill. However, only one of the two selected randomly will contain an active drug. What's the idea? The other is a placebo. Got to go back to definitions. We got to go back to definitions when we're answering these questions, saying how can we make it so nobody knows what they're getting? But one looks like this and the other looks like that. Well, we have to kind of give them both and keep them in a state of confusion. One last big topic to consider here. We have more pages than I thought. It'll be okay though. One last topic to consider here is block design. What is block design? Block design, here's a word you maybe don't know, is analogous to stratification. What does that mean, analogous? It means it kind of behaves in the same way. It's kind of a similar relationship. So what was stratification about? Different characteristics. Talk to a few of everybody with the different characteristics. Remember, we took simple random samples within each strata. Block, well, we're going to do something similar. We're going to put people together. It's a group of experimental units that's known before the experiment to be similar in some way. Okay, so they have some similarity. What's the idea? In a randomized block design, the random assignment of treatment to experimental units is carried out separately. Important word here, within each block. So, well, let's take a look down below. We've got an example down below. So blocking, we're going to put similar folks together, but we're not going to randomly select those similar folks. We're going to give some of them one treatment and some of them another treatment. What's this going to allow us to do? Allow us to observe differences in treatments for similar individuals. Maybe one type of person responds better to one type of drug. Maybe a different type of person responds better to a different type of drug. Blocking allows us to see those things. We just have to have some idea before the experiment which one of those characteristics makes the difference. We might not know that. So we got an example down below, AP example, as dogs age. Okay, sad. Dogs get older, their joints and their hips go bad. Such a reduction in activity can lead to other health conditions such as weight gain, lethargy. Lethargy get kind of slow due to lack of exercise. Studies conducted to see which of the two dietary supplements, glucosamine or chondroitin, these are the same ones advertised to old folks on Jeopardy, is more effective in promoting joint and hip health and reducing the onset of canine osteoarthritis. Ouch. Researchers will randomly select a total of 300 dogs from 10 large veterinary practices around the country. All the dogs are more than 6 years old. Their owners have given consent. Great changes in joint and hip health will be evaluated. So that's like the response variable. Hey, what would be the advantage of adding a control group in the design of the study? Well, what's a control group do? It acts as a baseline to see what are we measuring? Joint and hip health. Change when no treatment is administered. What happens when time passes? We don't do anything. What happens if we don't do anything? Time passes. We're seeing what's the effect of the passage of time. What do dogs' joints do if we don't do anything? Okay, B. Assume a control group is added to the other two groups in the study. Explain how you would assign the 300 dogs using a completely randomized design. I am going to skip B for the sake of time. You take a moment to describe a thorough hat method. What's the idea? 100 dogs for each treatment. Take a moment, make sure you can do a hat method. If you feel good about the hat method, we don't have to beat that to death. But part C is the interesting part. Part C asks us, rather than using a completely randomized design, one group of researchers proposes blocking on clinics, another group proposes blocking on breed of dog, blocking. How would you decide which of one of the two variables to use as a blocking variable? Well, for part C, block, just as you did with stratification, block on the variable that makes a more difference in joint hip health. I know you can't see that. Just as we did with stratification, we thought that one set of groupings, one group, the campus would make a different or a larger difference than gender. We thought the campus would have a larger effect on whether they like their buildings or not. Same deal here with blocking. What's going to make the larger difference? Do you think the breed of dog is going to make more of a difference or clinic? How would you decide? Well, you would see whether there are greater differences in joint hip health. See whether there are greater differences in joint hip health between breeds or clinics. I suspect it's going to be the breed of dog that has a greater effect on its joint and hip health rather than what veterinary clinic they go to. Big dogs, Great Danes, I don't know, Irish Wolfhounds. I suspect that they're carrying more weight. Probably their hip health degrades faster. What do I know, though? Certainly not a veterinarian. So we have blocking. Blocking puts similar folks together and it allows us to see differences between those similar folks. Great. So we're going to be making experiments. We're going to be talking about experiments. One of you guys might go get your PhD in something, get your master's in something, have to work in the lab and design some experiments. Some of you are in AP research right now and have to design your own experiments. What are the principles? Principles of experimental design, we got 4 of them. First one, obvious one, comparison. We need to have 2 or more treatments compared. We need random assignment. Use chance to assign the experimental units to treatments. Doing so, here's some important words. Some words you need to highlight, write down, circle, put a star by. Helps create roughly equivalent treatment groups of experimental units. How does it do that? It balances all the other things that we don't know about. So what's the idea here? This point 2 is really important. The idea then is if the only major difference is the treatment, then differences in the response may be caused by the treatment. That's what we were talking about earlier. We're talking about cause and effect. We want to say that this thing causes that thing. Well, it's going to be all these differences in these two groups. But if we randomly assign who's in this group, who's in that group, all those small differences are going to balance out. Make sure you've highlighted, help create roughly equivalent treatment groups. I'm going to come back to that phrase all the time. Okay, keep on moving. People with acrophobia. Oh, man. Acrophobia. Sometimes enroll in therapy sessions. All right, take a moment on this one. I think for the sake of time, we're going to pause. We're going to go through this one fast, though. You pause it. Try and fill it out. Take 5 minutes. Now we're going to do it. A, was the study an experiment or an observational study? Okay, you got your first thing you got to consider here. Take a moment. Read through it. Study was conducted. Participated in the study received a pill before each of the 2 therapy sessions. Oh, 17. Oh my gosh, randomly assigned. Okay, so what do we know here? This is an experiment. Why do we know treatments are randomly assigned? Part B says when the data were analyzed. Do you know data is a plural noun? When the data were analyzed, the D-cycloserine group showed statistically more improvement than the placebo group did. Based on this result, would the researchers be justified in concluding? What are we going to be justified in concluding? That D-cycloserine pill and 2 therapy sessions are as beneficial as 8 therapy sessions without the pill. Okay. D-cycloserine, 2 therapy sessions, 8 therapy without. Okay. So some people were randomly assigned D-cycloserine, some got a SIBO. After 2 therapy sessions, none of the 27 people received additional pills or therapy. 2 therapy sessions. Well, what's the problem here? You can see the problem. We're comparing 2 to 8. We never did that comparison. B. No. We never did experimentation on 8 therapy sessions. Okay, we got to make sure we read. That one's a tricky one. A lot of people miss that one because they didn't go back and say, oh, shoot, we talked about 2 up in the prompt. We talked about 8 in the conclusion. When you see that word concluding, perk up. Say, hey, this is a strong decision we're about to make. We need strong evidence. Part C, newspaper article that summarized the results of the study did not explain how it was determined which people received the drug and which people received the placebo. Suppose the researchers allowed the therapist to choose. Allowed the therapists to choose which people received the drug and which people received the treatment. And no randomization was used. Why might this lead to a bad conclusion? Let's take a moment and consider. I want to remind us how we can find solutions for these, and my hand's hurting. So let's take a look at the keyed response. Again, we're looking here, 2011, Part B. So let's take a look at how we can find an answer for something like this. Go back. Go ahead, go to Google. What are we searching for? AP statistics, free response, scoring guidelines. And we're 2011. Weird one here is this is Form B. You see that B? You got to type about it. So you go look Form B. Here we are. This was question number 2. So what is the problem? One example is if the therapists were allowed to choose, what could happen? They might assign the people with severe acrophobia to one of the groups and the less severity to the other group. What do they want to do? Therapist wants to look good, wants to look like they're good at therapy. How can they look good at therapy? Give the people that don't need much therapy the drug. Okay, the drug is amazing. Give the people who have bad fear of heights no drug. It's the drug did all the difference. Thus, the improvement after only 2 therapy sessions could be related to the initial severity rather than the effects of the drug. So we want to know that it's the drug doing the difference, not how bad your symptoms were to start. Take a moment, pause, copy some of that down, copy all of that down, and then we'll keep moving. What more to consider? This one. Look at this one. We're going to do this one in class or something very similar to it. We'll probably do that second or third day in class. Something to put off. If you want to do it yourself before, go for it. It's an old one, back from 2001. Special case, matched pairs design. This is a special case of the randomized block design. What does matched pairs make you think? 2 similar people. Sometimes this is good experiment and sometimes this is bad experiment. Here we have the Kelly twins. They're some astronauts. One was kept on Earth for a year. One was put up in the International Space Station for a year. Why'd we do this with twins? Why are twins such good subjects? Because the only appreciable difference between those twins was where they are and which one has a mustache, but they're about the same. That's bad. That's bad stuff. That's Dr. Mangala stuff. Don't do that. Consent is important for medical experimentation. We're not going to do systematic sampling. You can just go ahead and put a big cross through it. I don't know why I still have it there in the notes, but it's fun to make a big X. To make a big X. And then we have one more question. It's about matched pairs design. Let's take a moment to consider. Researchers are studying a new shampoo formula to compare the current condition of hair for people who use the new formula with the condition of hair of people who use the current formula. Okay, you're working for Pantene or whatever, and you're testing their new shampoo. 12 volunteers are available. Okay, you can't randomly select the people usually going to be involved in a study like this, but you can randomly assign them. Information on these volunteers, 1 through 12, is shown on the table. Okay, so we got some people, they're numbered. We know their genders. We know their ages, so we don't know how much else. Researchers want to conduct an experiment, involving the 2 formulas of shampoo. They believe something. They wouldn't tell us this unless it was important. They believe the condition of hair changes with age, but not gender. Because researchers want the size of the blocks in the experiment to be equal to the number of treatments, they will use blocks of size 2. So each block's going to have 2 people in it. Identify the volunteers that would be included in each of the 6 blocks and give the criteria used to form the blocks. So what does this say? Age matters, gender doesn't. If we're making blocks, similar people in blocks of 2. All right, so if we want to put similar to people together and we believe that age matters but not gender, then we're just going to sort them by age. We're going to put people as similar of age as possible together. Put subjects with the closest ages together. How are you going to do that? Don't just say put subjects with closest ages together. Tell me a little bit about the method you're going to use, starting with the two youngest and moving on one by one. And then next to until all 12 are in flocks. Sorry, my handwriting's bad. I'm going to write on. Part B, you're going to have this issue too. Other research believe that hair condition differs with both age and gender. Well, what are we going to do then? Pause, take a moment. Consider, well, what are we going to do now? Let's take a look at the key. How are we going to do this? How do we find the key? We go and look 2004. We're looking at number 2. Take a moment, try parts B and C, but then let's go look at the answers. Oh, I didn't answer part A. It told me to tell them who's going to be in each block. Let's finish our answer from part A. We're going to put the two youngest people together. We're going to put 1 and 2 together. Who's going to be next? Looks like 10 and 11. Who's next? We got some middle-aged folks. We got some 44-year-olds, 8 and 9. Who'd be next? Got a 47 and a 46-year-old. That's 3 and 12. We've got a 58 and a 60-year-old. It's 4 and 7. And our last two, 61 and 62-year-old, that's 5 and 6. Take a moment, you do the same things on B and C. Going to try and keep the video short, so let's go look at the scoring guidelines. Again, this is 2004, number 2. So when we're doing that, once again, going to Google, AP Stats, FRQ, scoring guidelines, and then this is 2004. Click on the one that says College Board. I'll trust the other one. Oh, this is Form B. We don't have Form B. There we go. That's quite, damn it. Well, what happened? None of these look right. Now we got to do it different. AP Statistics, FRQs. And then we go to the first one. And then we can go back and look for the year that we're looking for. Didn't work. 2004 FRQs. We're looking for scoring guidelines. You saw there was more data there if you want it. We're looking at question number 2. And then there's your answers for parts B and C. Take a moment, copy those down, fill those in, and that is the end of our 4.2 lecture. Notice what's different in part B. We blocked them by gender first. We put the two youngest women together, the two middle-aged women together, and the two oldest women together. And then similarly with males. And you'll describe something like that on part B. And then part C talks to you about how that doesn't make sense. So there you go. Make sure you filled that in. We'll see you in class.